Derivatives of a function. So the basic rules on differentiation of a presented here along with several examples. So remember that y fx is a function, then derivative of y can be represented by dy over dx, or y raised to 1 or f raised to 1, or df over dx. So in derivatives of function, we have the rule 1. So the rule 1 is the derivative of a constant. So the derivative of a constant is 0. So fx is equals to c them f raised to 1, then x is equals to 0. So to example, the differentiate is kx is equals to 30 to k raised to 1 to x is equals to 0. So that's the rule 1. So we have the rule 2. Rule 2, the power rule. So the power rule is the derivative of xn is n x then n minus 1. So to differentiate it is y is equals to x raised to 4 to dy over dx is equals to 4x raised to 3. So that's the rule 2. And next we have the rule 3. Rule 3. So in rule 3, the derivative of a constant times a function. So the derivative of kf x, where is k is a constant, is kf is x. So example, differentiate is y equals to 3x raised to 2. So in this case, we have f x is equals to x raised to 2, and then k is equals to 3. So therefore the derivative is 3 open and close parenthesis 2x raised to 1 equals to 6x. So that's the derivative. So next we have the rule 4. Rule 4. So in rule 4, we have the derivative of a sum or a difference. So if fx is equals to hx plus negative gx, then df raised over dx is equals to dh over dx plus in negative dg over dx. So example differentiate is fx is equals to 3x raised to 2 minus 7x. So in that case, kx is equals to 3x raised to 2, and then gx is equals to 7x. And so on dk over dx equals to 6x. and then dg over dx is equals to 7. So therefore, df over dx is equals to 6x minus 7. And next, we have the rule 5. Rule 5. So in rule 5, this is the product rule. So the derivative of the product y is equals to ux vx, where u and v are both functions. So of x is dy over dx is equals to u prime equals to dv equals to dx over dx plus v over du I over dx. So to example differentiate is fx is equals to 6x raised to 3 plus 2x open close parenthesis, then x raised to 3 plus 1. So let u prime and then x is equals to 6x raised to 3 plus 2x, and then v x is equals to x raised to 3 plus 1. So therefore, du over dx is equals to 12x plus 2, and dv over dx is equals to 3x raised to 2. So that's the rule 5, which is the product rule. So after this, we get df over dx is equals to open and close 6x raised to 2 plus 2x 3x then raised to 2 plus so plus x raised to 3 plus 1 and then 12x plus 2 equals to 18 raised to 4 plus 6x raised to 3 plus 12x raised to 4 plus 2x raised to 3 plus 12 plus 2. So equals to 30x over 4 plus 8x over 3 to 12x plus 2. So that's the rule 5, which is the product rule. Now we have the rule 6. Rule 6. So in rule 6, so the derivative of the equation fx is equals to u x v x. So where is u and v are both function of x. So is df over dx is equals to v du over dx u prime dv over dx over v raised to 2. Right. So example differentiate is fx equals to x raised to 2 7 over 3x plus 1. So let u x is equals to x raised to 2 plus 7 and v x is equals to 3x minus 1. So differentiate this to get du over dx is equals to 2x, and then dv over dx is equals to 3. So now using the formula for the quotient rule, we get df over dx is equals to open close parenthesis 3x minus 1, then 2x minus 6 raised to 2 plus 7 and then 3 over 3x minus 1 and then 2 I, and then df over dx is equals to 3x raised to 2 minus 2x minus 21 over 3x minus 1. So that's the rule 6, which is the quotient rules. So next is the rule 7. You have the rule 7. So in rule 7, the chain rule. So if y is function of u, y, and fu, and using u is a function of x, I, eu, and gx, so then the example derivative of y with respect of x is dy over dx is equals to dy over du, opening close parenthesis, du over dx. So example differentiate is y is equals to x raised to 2 minus 5, then 4, and then let u, so u is equals to x raised to 2 minus 5, so therefore y is equals to u raised to 4, u prime raised to 4, and then du over dx is equals to 2x, and dy over du is equals to 4 u prime raised to 3. So using the chain rule, we then got the dy over dx is equals to dy over du, open close parenthesis, du over dx. So next is we have the rule 8. So In rule 8, the derivative of in u prime. So when y is equals to in, then u prime is x. Then according to the chain rule, d over dx in u prime is equals to 1 over u, or du over dx. So the differentiate of in 2x plus 3. So in here is the differentiate is d over dx in 2